Hello, and today we are going to be illustrating the visual pathway, how we get information from the right and left field of view back to the occipital lobe. Now, I just want a little bit of a warning. This is for an undergraduate audience. It's going to do left versus right. We are not going to do superior versus inferior visual fields. There is a little bit of extra neuroanatomy there. So just be warned that if your course that you're in requires superior versus inferior, you might want to find a different resource. Now, as always, you could just learn this by memorizing a diagram, but I do find it much more functional to draw along with me. So what you're going to need is a red, a blue, and a black. Now, I do have the awareness that if you have some form of color blindness, that might not work for you. The red and the blue should look at least tonally different for most people with color blindness, but if you have profound color blindness, you might need an additional scheme. So I'll be talking about what color I'm using kind of throughout, even if it's a little bit redundant, just for those who might be facing color blindness. This is a really common color scheme in this type of illustration. What's not uncommon is the way I'm going to start here. So I'm going to draw some bars at the top, and your textbook might have the same method or it might have a different method. The textbooks that I have used a different method that I find more confusing. So this may or may not match. Now I am drawing these closed because I'm using this app in particular, and I'm going to go ahead and use my bucket tool to fill in red and the blue. This might take you a few extra minutes to complete compared to me. These represent fields of view. And so blue is going to represent our left field of view, and red's going to represent our right field of view. And I'm drawing two of these bars because you have two different eyes. And I'm in portrait mode right now, so I'm going to draw everything a little bit more squat than in real life. So you've got some squat eyeballs, and your visual pathway is going to be a little bit more squat compared to what you're going to see in your textbook, just so I don't run out of room before I get to some anatomy that I need to illustrate. And we're going to go all the way back to the right and left occipital lobe, which I'm not going to enter just yet. Now, again, this is your right eye, this is your left eye, but for both eyes, you have a left visual field and a right visual field. Therefore, they each get their own visual field bar. This is probably the thing that is represented differently. In your textbook, it might have a sort of fanning sort of thing with some alternate color scheme. I really like these bars, and you'll see why in just a bit. So we're going to be alternating between red and blue quite a bit because we're going to be following these fields of view all the way back to the occipital lobe. So let's start with the right field of view. So we'll start with our red, and we're going to consider the movement of light first. Now, the movement of light is pretty complex. We're going to simplify it a bit and treat it like a wave that goes in a straight line. It is more complex than that, but that's okay. It's a wave, it moves in a straight line for our purposes. The right visual field is going to hit the left retina. So I'm going to fill in this left retina here and show you how this left retina is color-coded in red to represent that it's picking up information from the right field of view. And that's true for the right eye, and that's true for the left eye. Right field of view goes to left retina. Now we'll go back to the right, and here on our optic nerve, this right visual field information is traveling to the right optic nerve. And here in the left eye, left field of view information is traveling in the left optic nerve. But let's look what happens here when we get to the optic chiasm. I'll go ahead and label that optic chiasm. That's an eye, that's an eye. There we go, optic chiasm. Back on red. Now, once the right field of view hits the left retina of the left eye, we're on the correct side for this information. So this is going to stay on the same side. This is ipsilateral information. However, this information that came from the right eye is on the wrong side. So it is going to do something called decusate. This information is decusating. Therefore, all of our right field of view information is going to end up in the left hemisphere. So just like this is the left eye, this is going to be the left hemisphere. I don't know why, but cursive is working better on my book. Okay, now I have added in the lateral geniculate nucleus. I can't remember if I made that a learning objective or not, but if anybody's coming from random parts of the internet and you need the lateral geniculate nucleus on either side, there you go. I'm going to go ahead and sort of illustrate a basic occipital lobe here in red to indicate that it is indeed right field of view information here. So we have something happen in the lateral geniculate nucleus. In my class, it does not matter what happens there. It's just that information keeps going. Now let's do the right eye and the left field of view information. So that light comes in, it does not bend, it goes straight. It's going to hit the right retina of the right eye. Likewise, left field of view enters the left eye and hits the right retina. And the same thing happens. We start off the same way when we're in the optic nerve. That visual information travels through the right and left optic nerve. This information, the left field of view information on the right eye, does not decusate. It continues on. However, the left field of view information from the left eye needs to decusate in order to meet up with the other left field of view information. And just as before, these do something in the lateral geniculate nucleus on the right hemisphere. We're not worried about what. They keep going, and they make their way to the right hemisphere occipital lobe. It's an O. Lobe, not an A. I just need to write everything in cursive and then it'll pick it up correctly. And that's it. So that actually helps to explain this region here, the optic chiasm, why you have an optic chiasm. The purpose of the optic chiasm is that information can decusate. We have a decusation site. Now it's about half the information. Basically, same side information needs to travel through the tracts together. That is the purpose of the optic chiasm. Now there's one further thing that I can teach you on an image like this. The reason that it's useful to memorize an image like this or learn an image like this is to talk about lesions that occur along the visual pathway. Now, I do on my worksheet have several lesions. I don't want to give away the answers to all of those lesions, but I can provide an example and the general technique for answering lesion questions on the visual pathway. So let's imagine this lesion this is not on any of my worksheets, but let's imagine it was this worksheet. The key to solving the visual deficit for this lesion is to go this way. And what I mean by that is we're going to follow this tract, we're going to follow this piece of information along its path and trace it out into the visual field in order to determine what the visual field deficit would be. We don't need to go this way. This doesn't tell us anything at all. This tells us everything we need to know. So let's go ahead and show you exactly what that means. So we take our lesion, and this one's fine. We don't need to worry about that whatsoever. This one is the one that's impacted. So we only are tracing it in this direction. We follow this out. We follow it. We follow it. We follow it. The reason I illustrated that wave of light is so that we can keep following that wave of light back out to our field of view, and the way we're going to phrase that is the left field of view of the right eye. So our deficit is to the left field of view of the right eye if the lesion is here, and we learned that by just tracing it all the way out, right? Now if you were to illustrate that, make sure we're on black. You've got two fields of view. We're only, in this case, dividing between left and right. We have a right eye and a left eye. Our deficit would mean that we are missing the left field of view of the right eye. Just like that. It would look like that in an illustration of your fields of view. All right, that's about it. Again, if you are learning this at the graduate level, you would need to be additionally concerned about quadrants, not just the divisions between left and right. There's a little bit of more anatomy in here that would give you that piece of information, but we're just not doing that because this is an undergraduate level class, and we're just not there yet. We don't need that extra piece. I hope this helped. Thank you so much for your time and attention.